Welcome to question 9 of the 2018 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So we need to consider a part of the graph of y equals x sine of x, which is shown. For part 1 of part A, it says given that the integral of x sine of x dx is equal to sine of x take x cos of x plus c, we're asked to evaluate the integral from n pi to n plus 1 pi of x sine of x when n is a positive even integer or 0. And we're asked to give our answer in the simplest form. So just a reminder that for this part of the question, n is even. So we need to calculate the integral between n pi and n plus 1 pi of x sine of x dx. And we know that that is equal to the antiderivative of sine of x subtract x cos of x. And we don't need to worry about the plus c because it's going to be a definite integral with a lower terminal of n pi and an upper terminal of n plus 1 pi. And now to evaluate that, we simply substitute in the upper terminal and then subtract away the lower terminal substituted in. So to start off, we're going to have sine of, and then replacing x with n plus 1 times pi, we have n plus 1 times pi. And then we have minus x, but x is being replaced with n plus 1 times pi, and that's times cos of x. And again we replace that with n plus 1 times pi. And then we subtract away from that the antiderivative with n pi substituted in. So we're going to have sine of n pi, subtract, and then we have x cos of x. So we'll have n pi times cos of n pi. And now our job is to simplify this down. So sine of n plus 1 pi, and if n is even or 0, we'd have things like sine of pi or sine of 3 pi or sine of 5 pi or sine of 7 pi. And all of those values are simply 0. And then for cos of n plus 1 pi, where n is even or 0, we'd have cos of pi or cos of 3 pi or cos of 5 pi. And we know that all of those values are negative 1 if we consider the unit circle. And then the same thing over here, sine of n pi, where n is 0 or even, we have sine of 0 or sine of 2 pi or sine of 4 pi or sine of 6 pi. And all of those values are 0. And for cos of values like 0 or 2 pi or 4 pi or 6 pi, we know that it has a value of 1. So simplifying this down, in the first bracket we end up with 0 subtract n plus 1 pi times negative 1. And then in the second bracket, which had the orange substituted into it, we would simply have 0 subtract n pi times 1. And now simplifying that down, so we'll have n plus 1 times pi. And then in the second bracket we have negative n pi with another negative here gives positive n pi. And that can then be simplified to 2n pi plus pi. And that was found by expanding those brackets. So that's a simplified form for this question. So from the examiner's report, we can see that only 17% of students got full marks for this question. And in general, students seem to find dealing with the parameter n difficult. Many tried substituting a specific value of n rather than using a parameter n, thus resulting in a specific solution rather than the general solution, which is what the question required. Quite a few students included the plus c in the definite integral, which was not necessary and appeared to cause them some confusion later in their working. For part 2 of part A, we're going to evaluate the same integral, but this time when n is a positive odd integer. So just to summarise that, we know n is odd for this question. So this one I'll go through a little bit quicker, but it follows exactly the same pattern as the first question. So we're going to have the integral between n pi and n plus 1 pi of x sine of x dx. And we know that that is equal to the antiderivative, which is sine of x minus x cos of x evaluated between n pi and n plus 1 pi. So as with the previous question, we're just going to substitute in the upper limit and then subtract away the lower limit substituted in. So that will give the following. And now, using similar logic to what we discussed in part 1, we're going to evaluate each of these terms down to its simplest form. So sine of n plus 1 pi, where n is odd, will now give things like 2 pi or 4 pi or 6 pi. So that is going to equal 0 for all n is odd. And then cos of n plus 1 pi, where n is odd, will give things like 2 pi or 4 pi or 6 pi. And we know for that cos is equal to positive 1. And then sine of n pi, where n is odd, will give pi or 3 pi or 5 pi. And sine, when we have numbers like that, is always equal to 0. And cos of n pi, where n is odd, will give cos of pi, cos of 3 pi, cos of 5 pi, or even cos of 7 pi, etc. And we know for those values that cos is going to equal negative 1. So now we just need to simplify this down. So in the first bracket we're going to have 0 minus, and it's going to be n plus 1 pi times positive 1. And then we're going to subtract away from that. And in the second bracket we're going to have 0 subtract n pi times negative 1. Simplifying that down, we get negative n plus 1 pi times 1 is just negative n plus 1 times pi. And then in the second bracket we have 3 negatives contributing to negative n pi. And in simplified form, this can be written as minus 2n pi minus pi. So that is the answer to part 2 of part A. So we can see from the examiner's report that less than 20% of students gained the mark for this question, and overall it was not well attempted. Students generally did not relate this question to the previous question, with many overlooking the fact that the cosine of a positive even integer multiple of pi was equivalent to the negative of an odd positive integer multiple of pi. So it really could have been shortcutted to reach that answer, or as we showed on the previous slide, we could have worked through it from essentially basic facts like we did for part A anyway. For part B of this question, we're asked to find the equation of the tangent to the curve y equals x sine of x at the point negative 5 pi on 2. Now, to find the equation of a tangent, we need to calculate the derivative first so that we can use it to find the gradient of that line. So this is a function x multiplied by sine of x, so we're going to use the product rule to differentiate. Now the product rule says we multiply these two things together and these two things together and then add them. So therefore our derivative dy dx for this function is going to equal x times cos of x plus 1 times sine of x. So that's the derivative. Now to work out the gradient of the tangent, we just evaluate the derivative dy dx when x is equal to negative 5 pi on 2. So we sub in the x value here into our derivative. So therefore the gradient of that tangent line is going to equal, and then we have negative 5 pi on 2 times cos of negative 5 pi on 2 plus sine of negative 5 pi on 2, and that is going to equal negative 5 pi on 2 times, and cos of negative 5 pi on 2 is simply 0, and then we add on sine of negative 5 pi on 2, which is minus 1. So that is just going to equal minus 1 as the gradient of the tangent line. But we're not done yet. We need to find the equation of the line, so we're going to use y subtract y1 equals m times x subtract x1 to do that. So therefore we have y subtract y1, where y1 is this value here of 5 pi on 2, and that's going to equal the gradient of negative 1, which we found before over here, and that's going to be multiplied by x subtract minus 5 pi on 2. So therefore we find y subtract 5 pi on 2 is equal to, and expanding this bracket we get negative x, and then this will be minus 5 pi on 2. So adding 5 pi on 2 to both sides of the equation just gives the rule y equals negative x. So that is the answer to part B of this question. And just so we can see what we've actually found, we've found at this point here, which was the point negative 5 pi on 2, 5 pi on 2, this equation of the tangent line is y equals negative x. And we've now got a sketch of it going through the origin just so we can see what's going on there. So from the examiner's report we can see that this question was answered well, and those students who had difficulty with the question were those who could not successfully differentiate, or those who substituted incorrectly once they'd found the derivative and the point that the line goes through. For part C of this question, we have the translation t maps the graph of y equals x sine of x onto the graph of y equals 3 pi subtract x multiplied by sine of x, where the transformation t is given by the matrix system below. A is a real constant, and we are asked to state the value of A, which appears in this position here, which we know from a matrix system is a translation in the positive or negative x direction depending on what value of A we put there. So in reading time, hopefully you had a look at part D and you would have seen this graph, where we can see the graph of y equals x sine of x has been translated 3 pi units in the positive x direction to give another graph that is described in more detail in part D, which we'll come across in a moment. So because we know the graph has been translated 3 pi units in the positive x direction, we know that A is simply equal to 3 pi. So that is the answer to part C of this question. So from the examiner's report we can see that 34% of students got this question correct, and that overall many students answered this question well. Negative 3 pi was a common incorrect answer to this question. For part D, let f have the domain 0 to 3 pi, where the rule of f of x is 3 pi subtract x times sine of x. And G also has the domain of 0 to 3 pi, where its rule of g of x is equal to x take 3 pi times sine of x. So L1 is a line that is a tangent to the graph of f. So L1's here, and it's a tangent to the graph of f at the point pi on 2, 5 pi on 2. So that's that point there. So that means that this slightly more bolded line has the rule f of x equals, and it was 3 pi take x times sine of x. And the line 2, which is down here, is a tangent to the graph of g at the point pi on 2, negative 5 pi on 2, so that's that point there, which means the slightly thinner graph shown has the rule g of x is equal to, and it had the rule of x take 3 pi times sine of x. And all of that information is shown on the diagram that we've started annotating. For part D, the crux of this question is to find the total area of the shaded region as shown in the diagram. So there's a fair bit that we need to take into consideration when we're doing this question, and parts A, B and C have all led up to this part, and we're going to need to use information from every single one of those previous questions to answer this efficiently. So first of all, from part C, we know that the graph that's shown in the bottom right here was translated 3 pi units in the positive x direction to give the graph that's bolded in the diagram above. And we know that on the original graph of x sine of x, we found a gradient at the point negative 5 pi on 2. And if it's translated 3 pi in the positive direction, it becomes a gradient at positive pi on 2. So that means that the line L1 is now going to have a gradient of negative 1, so it's going to be y equals negative x, but now it's going to have the rule y equals negative x plus 3 pi. So that means that the coordinates of this y-intercept are now 0, 3 pi. And now by symmetry, a similar argument can be made about the coordinates down here, which are going to be 0, negative 3 pi. And we also know that up here, we end at 3 pi. So that forms 3 vertices of a triangle where the shaded region is related to. So we're going to need that information in a moment. So the shaded region could be found by the area of that triangle. Subtract away the areas of all of the white regions that have been removed. So we're going to label this area A1, and it's going to be from the x-axis and bounded by this curve, which has the rule of f of x. And then we're going to call this region A2, and it's going to be bounded by the x-axis and this curve here. And then finally A3 is going to be this area just here. So that is A3. On our simpler graph of just y equals x sine of x, which is reproduced down the bottom right of this screen, we know that this region here would be equivalent to A1. This region in here would be equivalent to A2. And this region here would be equivalent to A3. So with that in mind, we know the area of A1 is going to equal the integral between 2 pi and 3 pi of x sine of x dx. And now thinking all the way back to part A, we had an expression in terms of n for that integral. So we know that that integral is equal to 2 pi n plus pi, where n is an even number. So in this case, when n is equal to 2. And that would then simplify to 4 pi plus pi is 5 pi. So that is the area of A1. Next, we're going to consider the area A2, which was in green. And that area on the simplified graph of just x sine of x would be equal to the integral between pi and 2 pi. But because it's below the x-axis, we're going to put a negative out the front to make this value positive. And then inside that integral, we're going to have x sine of x dx. So that is going to equal, and that's going to be negative due to the negative out the front. And now the n value we're going to select for this is odd. So we need to remember that that had an expression negative 2 pi n minus pi. And for this, we're going to select it when n is equal to 1. So that, when we do that, is going to give minus 3 pi with a negative out the front is positive 3 pi. And the last area, A3, that we need to find is going to be the integral between 0 and pi of x sine of x, our simplified graph. And that is going to equal, like the first one, 2 pi n plus pi, because we're selecting an n value that is 0 or positive. And in fact, when we do this one, we're going to have when n equals 0, and we get that that is simply equal to pi. So we now have the areas of A1, A2, and A3. So now we need the area of the triangle, and we need to subtract 2 lots of each of those areas to get the shaded region. So the area of the shaded region, which is what we're asked to find, is going to equal the area of the large triangle, subtract away 2 lots of each of those areas, A1, A2, and A3. So the large triangle has a base that goes from negative 3 pi to positive 3 pi on the y-axis, so that's going to be 6 pi. So we're going to have a half times the base of 6 pi, and then the height of the triangle is the length along the x-axis, which is 3 pi. And then we're going to subtract away from that 2 lots of the area A1, which is 2 lots of 5 pi, 2 lots of the area of A2, which is 2 times 3 pi, and we also need to remove 2 lots of the A3 area, which is just pi. So that is going to equal, and we're going to simplify it all in one step. So a half times 6 pi times 3 pi gives 9 pi squared. And then we're going to subtract away from that. 2 times 5 pi is 10 pi, plus 6 pi plus 2 pi is 18 pi. So that is the answer to part D of this question. So from the examiner's report, we can see that this was an exceptionally difficult question. So only 4% of students got full marks for the question, and 6% of students made some progress, with 89% of students receiving 0. Students who recognised that the graph of this question was simply a combination of a translation and reflections of the earlier simple graph that we were dealing with, and then used symmetry to determine the areas under the curve, were far more successful. Some students were able to see that the shaded area was simply the area under the curves, subtracted away from the area of the larger triangle. Students who determined the equations of tangent lines to find the areas between the tangents and the curves were rarely successful due to the lengthy calculations that were involved to get that answer correct. And as you can see, just put on this slide is what would have happened if you didn't recognize some of the simplification that you could have performed, which we did in the actual working through of this question. And I won't talk to all of this, but you can see that it's quite a nasty set of calculations that you need to perform if you didn't do it using the simplified x sine of x rule, which we did on the previous slide.